Let me describe a problem that happens to every QA engineer who starts automating without a plan. You write 50 Selenium tests. The app works great, your tests pass, life is good. Then the development team updates the login page. They move the username field, rename a button, change a CSS class. Suddenly, 20 of your tests are broken. Not because there is a bug in the app, because your locators are hard-coded in 20 different places. You spend half a day updating the same selector in file after file. This is the nightmare that the page object model was designed to prevent. The page object model, or POM, is a design pattern where each page of your web application gets its own Python class. That class stores all the locators for that page and all the actions you can take on it. Your test files never interact with the DOM directly. They only call methods on the page object. When a locator changes, you update it in exactly one place, the page class, and every test that uses that page instantly works again. POM is not optional at scale. It is the difference between a test suite that takes a day to maintain and one that takes a week. And beyond maintenance, POM makes your tests more readable, more reusable, and easier for new team members to understand without needing to know anything about the application's HTML structure. Let us break down exactly what the page object model gives you. First, it gives you a single source of truth for locators. Every element on a page is defined once, in one class. Second, it gives you a clean API for your tests. Instead of your test saying, driver.find_element by .id username.send_keys email, your test says, loginpage.enter_username of email. The test reads like a specification. A non-technical person can understand it. Third, it makes your tests resilient. When the UI changes, only the page class needs to update. Your test logic stays the same. Fourth, it makes your code reusable. The login page object gets used by every test that needs to log in. You write that code once and reference it everywhere. The structure is simple. You have a pages folder with one Python file per page. Each file contains a class with an _init_ method that takes the driver, and methods that represent user actions. Your tests folder imports the page classes and calls their methods. That is the entire pattern. It sounds simple because it is, but the discipline of applying it consistently is what separates professional automation engineers from people who write scripts. Let us build a real page object class from scratch. We will model a login page. Create a file called pages/login_page.py. Inside, define a class called loginPage. The _init_ method takes self and driver as parameters and stores the driver as self.driver. Now define your locators as class-level tuples. Username_field equals by .id, username. Password_field equals by .id, password. Login_button equals by .css_selector, button open bracket type equals submit close bracket. Using class-level tuples means your locators are easy to find, easy to change, and separate from your logic. Now write your action methods. Enter_username takes self and username, and calls self.driver.find_element*username_field.send_keys of username. Do the same for enter_password. Write a click_login method that finds and clicks the button. Write a get_error_message method that reads and returns the error text when login fails. Finally, write a login method that calls enter_username, enter_password, and click_login and sequence, a convenience method for the full login flow. That is a complete, professional page object. Keep your locator tuples at the top of the class, your private helpers in the middle, and your public action methods at the bottom. This ordering makes the class easy to read at a glance. Now let us use the login page in an actual PyTest test. In your tests folder, create test_login.py. Import your login page class at the top. In your contest.py, you already have a driver fixture that yields a Selenium WebDriver. Now write your first test, def test_successful_login takes driver as a parameter. Inside, create a login page instance, page equals login page of driver. Then call page.driver.get of your login URL. Then call page.login of valid_email, valid_password. Then assert that driver.current_URL contains dashboard or whatever URL the app redirects to after login. Write a second test for failed login, def test _invalid _password also takes driver. Create the page, navigate, call page.login with the wrong password, then assert that page.get_error_ message is equal to the expected error text. Look at how readable these tests are. They read like plain English. They contain zero locator details. If the login button selector changes tomorrow, you update one line in login_page.py, and both tests still pass. That is the power of POM in practice. Real applications have many pages, and your page objects need to connect. Here is how to handle navigation between pages using POM. When a user logs in successfully, they land on a dashboard. So the click_login method in your login page should return a dashboard page instance when login succeeds. This is called a page transition return, and it makes your tests flow naturally. In your test, after page.login, you get back a dashboard page object and you can immediately call methods on it. This keeps your tests clean without needing to know what URL they are on. Create your dashboard page the same way, a class with its own locators and action methods for things like navigating to settings, checking the user display name, or logging out. You can also create a base page class that all your page objects inherit from. The base page can hold common methods used on every page, things like wait for element, scroll to element, or take screenshot on failure. By centralizing these utilities in base page, you avoid duplicating the same helper code in every page class. As your test suite grows to cover 10, 20, or 50 pages, this structure stays clean and navigable. Any new engineer joining your project can find any locator or any action in seconds. Here is your recap. The page object model solves the single biggest maintenance problem in Selenium automation: locators scattered across dozens of test files. Each page in your app gets a Python class. Locators are defined once as class-level tuples. Action methods represent what a user can do on that page. Tests call page methods, never interact with the DOM directly. When UI changes, you update one file. Page objects can return other page objects when navigation happens, keeping test code readable and linear. And a base page class centralizes common utilities for all pages. If you apply POM from the start of your automation project, you will spend far less time fixing broken tests and far more time writing new ones. In the next episode, we are leveling up with data-driven testing. You will learn how to run one test function against dozens or hundreds of different inputs using PyTest's parameterized decorator. If you are testing a form, a search box, or any feature that accepts variable input, data-driven testing will cut your code volume in half while multiplying your coverage. That is episode 16. Subscribe to QA Career Lab and I will see you tomorrow. If this series is helping you build toward an automation engineering role, drop a comment below. I read every one and it helps me understand exactly what to cover next.